What a lovely introduction. Thank you so much, Father Alan. It's really lovely to be here in Philadelphia, and thank you so much for being so kind there. Someone will know I'm also a trustee of the John Templeton Foundation, whose offices are just around the corner in Conshohocken. It's wonderful to see some colleagues here from them as well, and for your kindness in allowing, kindness to me is also, I suppose, kindness to yourself. You didn't have to pay an international airfare because Templeton were doing that as well. We've just had a wonderful weekend working on the Templeton programme right here in town, which has been lovely. So let's get on with the story, because I know we've got till 5:30, and I want there to be some discussion, especially with the students. I'll try not to mention the book too many times, but that's what it looks like. And that, by the way, is York Mint. So do come and visit us in York if you're ever the other side of the pond. Glorious medieval. Minster Cathedral. Let's get right on this project. So yes, I do this. I'm very flaky and interdisciplinary now, but for 25 years, I am a scientist now. I'm a physicist, what's called a soft matter physicist. Most of the soft matter is here, but we also study it. The physics of polymers, plastics, the physics of biopolymers. So science is with the core of what I do. But I've always loved sharing the sort of scientists we do in universities with high schools. And because I'm passionate about the connectivity of disciplines, science and arts, but also the history of science and science and theology, science and religion. That's a question that's always going to be answered. That's an issue that's never going to go away. I get invited to high schools, and I love talking with the pupils there. And we have fantastic discussions. And what pains me, you might know that in the UK we have this very, very narrow high school educational system, that after the age of 16, it is still true that pupils are often entirely sciences or entirely humanities. So it's possible. I can see some of you getting all excited. Why aren't I over there? You mean I could drop all my sciences when I was 16? That sounds great. Well, but when I ask them why not, I don't mind, it's fabulous that people are studying history and French and English. Why wouldn't you study those wonderful subjects? But if the reason you're not choosing science is this, something is wrong. And I heard too many times the sort of thing, I didn't choose science because I saw no room for my own imagination or my own creativity. And it's obviously the way that scientists, we've been very bad at communicating what science is really like. It's also out there in the media. It's something that we put in a big shiny box that only experts can do, and there's a formula and there are facts you learn, and the creative side of it seems to have been bypassed by much of our education and media. So I set out to find out what's been going on here. And of course, one thing that's been going on is we have shadows from earlier, from the last century, the 20th century shadow. This is C.P. Snow, British government scientist, who famously coined this term, the two cultures. I don't know if anyone if that's a phrase that's still valid this side of the pond. He gave what's called the Reith Lectures, BBC broadcast Reith Lectures, and a book in which he said, I won't read this out, but his complaint was that in Britain at least, political leaders were all of this Oxford and Cambridge and humanities classics background. They didn't understand science. That science was a sort of second rate and didn't have anything to do with culture. In other words, people would complain that how uncultured scientists were and how little Shakespeare they knew. But when he challenged them to have a conversation on the second law of thermodynamics, which for C.P. Snow was just as much a cultural, human, imaginative achievement as Hamlet, they had nothing to say and were proud they had nothing to say. That was his issue. So we suffer from an inheritance of division between the two cultures. But it's not just the 20th century. The 19th century has something to be blamed for as well. We'll be revisiting the Romantics just at the end, but here's John Keats, the great Romantic poet. Unusually, he's a trained doctor. He had a medical degree, but famously was not a fan of the the desiccation, the drying up of imagination that he thought science was doing in culture. So this is a famous little excerpt from a long poem he has called Lamia. Do not all charms fly at the mere touch of cold philosophy? This is, of course, before the word scientist was invented. Philosophy is natural philosophy, it's science. There was an awful rainbow once in heaven, an awe-inspiring rainbow. That is, of course, we know her woof, her texture. She's given in the dull catalogue now of common things. Philosophy, science, will clip an angel's wings, conquer all mysteries by rule and line, empty the haunted air and gnomed mine, unweave a rainbow. So in fact, Richard Dawkins probably borrowed on this for one of his books, Reweaving the Rainbow. Does science really unweave the rainbow? And it leaves nature in tatters. Previous century, 18th century shadow. Now, William Blake. This is William Blake's. William Blake, well, the great. You can't classify Blake, can you? I mean, he's pre-romantic. He's late classical. He's theologically. His imagination incarnate. There's a wonderful, if any of you are in London in the next couple of months, there's a fabulous Blake exhibition on at the Tate Modern in London, his art. Now, so this, including this picture, this is Blake's picture of Newton at the bottom of the sea, with all of nature around him and above him, and yet Newton still stares at the floor with a pair of dividers. Mathematizing nature. And this is Blake. My task is in the grandeur of inspiration to cast off rational demonstration, to cast off Bacon, Locke and Newton. I will not reason and compare. My business is to create. So this is, as far as I know, this is the earliest where I have discovered, this is where the divergence seems to happen. The earliest statement that science is not in the business of creation. It might be reasoning, it might be comparing, but it's not creativity. And yet, is that really true? Is that the experience of scientists? Well, I mean, let's ask a few. Let's ask Ada Lovelace. Now, she ought to know. Great pioneer of computational mathematics. She was also Lord Byron's daughter, of course. But did you know that as well as writing mathematics, she wrote poetry herself? Very interesting poetry. Well, how could you? Byron's daughter. Well, she's her own poet. Listen to what she says about doing mathematics or science. Those who've learnt to walk on the threshold of unknown worlds by means of that are commonly termed par excellence the exact sciences. I love what she calls scientists. Did you catch it? Those who walk on the threshold of unknown worlds. I think, if you ask me again, would you want to be called a professor of science or professor of natural philosophy? I might ask, no, I want to be called a professor of someone who walks on the threshold of unknown worlds. That's the best description of a scientist I could ever. May then, with fair white wings of imagination, hope to soar further into the unexplored amidst which we live. She also recorded in her autobiographical notes that when she really wanted to write poetry, she had discovered that the best way of getting herself into the mindset of writing really fresh poetry is to spend a week doing mathematics first. There you go. So something else is going on here. And of course, by this stage, I was also self-reflecting and talking to as many scientists that I could meet about their own processes of coming up with the new. I did actually meet Richard Feynman once, lucky me, when he came to Cambridge just before he died, actually, to give the Dirac lecture. I didn't talk to him very long, but he was a great inspiration to me as a young scientist when I was such. But he records a conversation about this topic with an artist friend of his who says, you scientists, you don't imagine, you have no imagination, no artistic imagination, you have no aesthetic feeling for the world. And he got into kind of argument about this, and said, yes, we do. In fact, although I might not have as refined an artistic, aesthetic appreciation of art as you, nonetheless, there's a sense in which scientists see more. Because he says, when I see a flower, I don't just take in the beauty of the flower. I imagine the structure of the cells and all the biochemicals and the processes inside the flower at microscopic levels of detail, which have a beauty all their own. And then the evolutionary process by which those colours evolved, and the fact that the insects that pollinate the flowers have photoreceptors in their compound eyes that see in the ultraviolet light in which those flowers are giving. And there's a sort of whole connectivity of beauty in the fabric of life forms that I see. And so surely science sees more. I don't understand why it's less. Oh well, while we're talking about scientists, we should probably meet him, shouldn't we? Einstein, imagination is more important than knowledge. Knowledge is limited, imagination encircles the world. And Einstein actually, on several occasions, said that he felt he was more like an artist because the role of a scientist is to reimagine the universe. You can't deduce from observation what the universe looks like at all these scales and how it works. Well, let's reimagine it. So, I set off to have this conversation. I had huge fun over a number of years talking with chemists, musicians, poets, artists, writers, mathematicians, physicists. The scientists I have to get just a little bit relaxed with a glass or two before they understand, no, I'm not asking you to tell me the journal article version, the sweet polished version of what you've discovered. I want you to tell me the story of your imaginative journey, of your creative journey. I want to tell me where the idea first came from. Tell me the ups and downs. Tell me the wrong routes. And I had a series of conversations. The pictures on the right are illustrative of a story I myself was involved in, trying to understand the physics of hot, sticky liquids that are both elastic and flow. It's what happens in the polymer industry. I understand that the hotel I'm staying in tonight was used to be owned by Exxon. Is that right? I used to consult for them a long time ago before they got a bit iffy about climate change, and I went to work with other industry. But that's another story. But I got fascinated by this science. And it turns out that we years and years spent trying to understand how this complex system of entangled molecules works. And all sorts of attempts were made to understand how this viciously molecular noodle soup could possibly be understood. And then some people had, a Japanese and a Welshman, Doy and Edwards, had this beautiful, simple view. And so what if I'm a string in a whole tangled mess of other strings? It's as if I've trapped in a tube, like this picture down there, the red string. So I can move easily among like a snake through the tangled web of strings, but I can't move sideways very far. I get entangled. So maybe we can reduce this complex system to one simple thing. That was one conversation. This is Ken Hay, who's Professor of Art at the University of Leeds, where I was at the time. And I sat down with Ken. I said, well, Ken, tell me what it's like being an artist. Because he's an artist himself. All the professors of art at Leeds are also artists themselves. And he talked to me about a project he'd recently been involved in, well, he created, called Stalingrad, which is also called Backgrounds to History. He had some black and white, very grainy photographs taken in the Battle of Stalingrad, which you probably know as this awful Second World War disaster of war where all the soldiers froze to death. And I mean, it was Germans invaded Moscow, but don't invade Russia in the winter. It's a bad idea. And but what Ken wanted to do was to use art, to use mixed media to help people think of the life and the suffering and the meaninglessness behind the photographs. And he set up, well, I think he told me what he was trying to do, and then he told me the story of how the first idea didn't work. He did an experiment and it didn't work, so he had to scrape the canvas clean and try something else. And then he tried a number of different patterns, colours, shadings, creations, and he went through a number of hypotheses about what visual structures would achieve the engagement he wanted. And can you hear from I'm trying to sort of shorten the conversation, and I was amazed. I said, well, Ken, it sounds exactly like our stories. We're trying things too. This is eventually how he did it, and it doesn't do justice to the real works. But the photographs are off to the one side, and there's extraordinary patterns that brings your gaze back. You end up in the field of blood or the field of poppies, where they are. And your gaze comes back to the picture. There's beautiful pictures, and he eventually solved it. But it was a very, very long journey. And I said, there's something here. There's something we have in common about our journeys. Right. So I want to summarise in the next 2 slides what I found. And then if you're then you'll know whether you want to read any more, and you can buy the book cheaper when you get the form. And I want to talk a little bit about the types of creativity, or the modes of imagination, and then a little bit about a story, and then I'll add some detail to that before we finish. So, when you write books, and I'm sure you're all going to be writing a book sooner or later, you will find that there's a sense in which books write themselves. Now, I don't mean to say it's not hard work, but very often you start off writing a book, and then the book says, no, you can't write me. So the book I thought I was going to write was a book that told all these scientific stories of creativity, and I had a number of chapters on the music and the poetry and the art, right? Told those stories. And then a nice undergraduate essay, to finish off the two, to compare and bridge between them. Can't write that book. You can't write that book. And the reason you can't write it is because imagination doesn't group itself that way. There were far too many commonalities. So I had to restructure the book. And there are many ways of doing this, but the system that worked for me is to talk about 3 modes of creativity. And the first is the visual. Some, but not all people, think visually. Well, clearly visual artists think visually, that's what they're doing, right? They're presenting. Many scientists think visually as well, not mathematically, not in words, they think in pictures, they think in moving pictures. I'm one of them. And they think in pictures, they jump between different pictures. And so this whole metaphor of the visual, after all, if the visual imagination is so powerful, it becomes the metaphor for understanding, doesn't it? What do we say when the penny finally drops? We say, I see. No, not because we've actually seen something, but because the visual metaphor is so important to us. Other people don't think in pictures, they think in words, in language. Wittgenstein, of course, told us all about this. This pudding sometimes gets over-egged. You will find since ancient times, actually, there's been a school of thought that says, well, I can only think in words. We can talk about that. I don't believe it's true, but many people do. Clearly, poetry, narrative is words. But there's an extraordinary entanglement between the history of fictional writing, and particularly the early English novel, and the origin of experimental science, which I want to explain. I know that's going to sound weird, but it's true. Throughout the centuries, the idea of a scientific experiment and the idea of telling a story are deeply linked. And that's one of the ways in which our humanities disciplines and our sciences need to get talking to each other again. So that's words. And that's probably should be it, shouldn't it? Because what else is there? So if I have no pictures and no words, then I should have nothing, right? I just have a vacuum. But I don't, because there's a whole abstract mode, and this is the transcendent, mystical wonder where mathematics lives and where music lives. I wonder why they both live there. And so one of the little sub-projects within this overall scheme of thought became, look, what is this thing about maths and music? Why do people take it as almost, I've heard 100 times, oh, little Sarah, yes, she's great at the clarinet, so she's obviously going to be good at maths. Really? Why? Does it really follow? Sometimes it does, but we're going to explore that. So that was the first thing. The scientific and the humanistic creativity get entangled across at least these 3 modes of creativity. But I could use posh words, let's call that the synchronic commonalities. But there are diachronic commonalities as well. There's a story. And by the time I'd heard this story from Ken, from myself, by the time I'd heard it for the 50th time, I realized there's something going on here. There's a pattern. I wouldn't say there's not an exact form, it's not an exact imprint, but there's a story of how human creativity works, whether you're writing a poem or whether you're devising a mathematical proof. It goes something like this. For some reason, you get a dim vision. Aha, I want to write a poem about this. Ken, I want to write something that I want to create a piece of art that reflects the Battle of Stalingrad. I want to create a theory of polymers on the move. I don't know quite what the question is yet, even. I know it's like a dim mountain peak seen in the mist. And what that does straight away is to generate a desire. Now here's another thing. I was surprised to learn over and again that the assumptions that we make, that there are human activities that are cognitive and clean and emotionless and all brain and all left hemisphere or something, pure mathematics, for example, theoretical physics, you know, and there are other arty, you know, painting, poetry. There's all emotional, dripping with affect. You know, that this doesn't work at all. That's all a big lie. What's more, through any creative process, the emotional contours and the cognitive contours of the story weave into each other all the time. So we've got some sort of intellectual vision, and immediately that gives rise to desire. And it turns out that if you're ever, you know, if you're writing every doctoral student knows this, you know, it's only the desire to solve that problem, to write that thesis, to solve those issues in the end that keeps you going through the desert of year 3 and 4, whatever it is, you know. So there are a series of attempts. You try to create. But that gives rise to the experience of constraint and failure. One never gets this right first time, whether as a scientist or whether an artist. It turns out that at the same time I discovered, while the scientists were being a bit quiet about the part of their stories that are more imaginative and more creative, something about this, you know, they're all, you see, we're all very good at talking about the scientific method, but what we talk about, when we talk about the scientific method, we only really mean the second half of the scientific method. The scientific method is all about hypothesis testing. We have an idea, it predicts certain experimental results, we do the experiments, we make the observations. Have our theories correctly predicted them or not? Yes, good, we keep the theory. No, okay, we have to change the theory. That's the scientific method. But if you think about it, it's only the second half, because no one ever, and Popper and the philosophers of science, no one ever told us a method for getting the ideas in the first place. That's, you see, you can't even start science until you have the imaginative, scientific imagination. I don't know why it's taken me 30 years to realise this. And I reflected back on my own formation as a scientist. And when I was doing my PhD, did anyone ever sit us down one afternoon in all those years and have a conversation about what sort of lifestyle, work style practices might be more conducive to the scientific imagination for getting good ideas? Do you do it here in Villanova? Anyone doing science here? Does anyone ever sit you down and talk about having good ideas? I guess not. No. Well, we could have a conversation about the module for scientific ideas. So we experience constraint and failure. And then, if we're lucky, sometimes we have to leave it to one side for weeks, for days. You know, sometimes we can never go back to it. Sometimes it's days, months, weeks, maybe years later. But at some point, it turns out that when we thought, you know, our impression is that we are no longer grappling with this problem. We have really thought about it for a long time. And then we are walking in the woods, going for a run in the lake, whatever your thing is, on your sailboat, in a shower, getting off a bus. Probably getting off a bus, actually. If I had a fiver, as we say in the UK, for every time someone told me the great idea they had getting off a bus. So by the way, guys, when you're interested in getting good ideas, you just travel by bus all day, every day. Keep getting off, but they'll come, I promise you. I think you have to do the hard work first, actually, but there's this upward, this aha moment. And now, even then, you haven't solved the problem. You just kind of know you can. And you know the route through the forest that you got tangled up in before. You found the right path, then you will get to the mountain peak. And then there's this other aesthetic of this emotion. That gives you an emotional response in itself as a final coming home when you've done it. So that's the creation narrative. and I don't know if you know, there's a number of books or schemes of 7 great narrative plots. So Christopher Booker wrote a book that he called The 7 Great Plots. I'm sure if you've done English lit courses, you at some point you'll categorize your stories into the 7. In every story is either the battle of good and evil, boy meets girl and everything's happy. That's the boy meets girl and everything that's unhappy. That's the tragedy. Trying to find your way home. That's the Odyssey. or Apollo 13, or whichever story you have it. But there's a story that Chris Booker missed out. It's the creative narrative. And I don't mean the creation myth, and of course, actually, he could have had that one as well, couldn't he? Every scientist, every civilization has creation myths. No, this is the story of how humans create things that were not there before. It's one of the activities that makes us human. And that's the story. Okay, see what you think. Right, so the rest is details. So, quarter now, I will add a bit more flesh to those bones, and then we can have some questions. So I'm not going to, in the time I have, I'm not going to be able to do any more about the story. So you can just come back and ask me about the narrative. What I'm going to do is to say a little bit more about those three modes of imagination. The story will perhaps emerge. Einstein was a visual thinker. Look at what he says. The elements of my thought are visual and sometimes even muscular, sort of haptic type. He says he had to seek for the words afterwards. And then I'm in Philadelphia, so I have to show you my favourite Monet. This hangs in the Philadelphia Museum of Art. Go and see it if you've never seen it. It's only relatively recently come into public views in private hands for many, many years, nearly 100 years. It's the Pines. And I spent a happy morning, thanks to Marianne, who's just joined us actually, who put me in touch with the European 19th century art curator in Philadelphia Art Gallery, and she taught me through this wonderful painting which has mesmerised me for years. This doesn't do any justice. You have to go and see it. Though you can see the trees waving. You can feel the evening breeze. You know it's an onshore breeze. He was at Antibes. He went to the south coast of France. You can see how that sea is ruffled. You know where the sun is. It's setting on the right-hand side, isn't it? Because you can see the redness illuminating those pines from underneath, blood red, and the yellow top of the sun is lighting up the grass on the floor. It's a theory. In the ancient sense of the word theory, the studied impression of a formal, frequently religious event. By experienced onlookers, this painting offers the perfect theory of nature at that moment and place. Oh, that's a little bit from the book. So accurate is Monet's conjuring up by visual imagination representation of that moment that when Van Gogh went to that place, he was reminded of the picture that hung in his brother's shop, which is almost certainly this one. It's not, paintings are supposed to remind you of places, right? But this is so good, it worked the other way around. Why, I should just say, why would I want to write about Impressionistic art? There's something one level deeper about Impressionist art. For the first time, so the art historians tell us, the Impressionists created the canvas itself as a proper object of visual inspection, as well as the represented scene. And when you know what happens when you go and see a Monet, you're always walking up to it to see the brushstrokes, and then you're walking to the other side of the gallery, yeah, and you have this double vision. That's what theoretical physics is like. It's a wonderful metaphor for theoretical physics. When you do theoretical physics, you're writing your model. You're creating a mathematical model, a physical working model, in perhaps slightly blurred terms. You're not capturing every aspect of the world, but you're capturing the aspects that matter. But you must never confuse the model, the scientific model of the world, with the world itself. Any more than you should confuse the canvas, though it is an object of beauty and structure, all of its own, and representation, with the world it's representing. So you see, we have this double vision. What is also more is that in doing physics, I can only talk about physics, it's the science I do, that it is equally important to do close inspection and stand back all the time. There's this oscillation between the details and the overall picture. How else can vision help us? Well, let's go right back to Plato. We should have gone back to Plato a long time ago. Plato's original theory of vision, some of you might know, is called extramissive. Now, it often causes us pause. We think it's strange that the ancients thought that when you looked at something, rays were emerging from your eyes, not entering them. Now we understand vision as being intromissive, right? Light comes into our rays. Plato thought this was ridiculous because if this were really true, we'd be confused because light would be coming into our eyes from every which way, every object in the room. There's no way we could sort out what we were looking at. Clearly, we are placing our gaze in different places. You're looking at me, you're looking at the picture. Aristotle didn't agree and pointed out that there were issues of dark rooms here, but if you turn the light off, we can't see anything. If we were sending out the rays, we'd have our own torches with us, wouldn't we? But the extremissives could get around that easily, and there is a sense in which they were right, because if you understand vision, if we start to understand vision not just as the optical part that finishes on the retina, but the entire process of perception that involves the brain as well. And St. Augustine knew all about this in terms of how music worked. He knew that the soul, or what we want to think of as the mind, was always projecting. The way he put this problem was that how could the soul be just passive? It can't be just passive, it should be active. And because the mind does have to be active, and we know that the mind perceives in what we now call a Bayesian way, that we are making sense of what we see only because we continually create interpretations of them, project that forward into our mind, and see how it could interpret the incoming signals. Otherwise, if that were not true, now, does anyone see the emotion there? Can you see? Yeah, can you see the wheels turning? Now, of course, the trouble is, you'll tell those who see the wheels going around. This is Ashoka Kitioki's, one of his wonderful rotating snakes illusion. You'll think I've just got a moving GIF here. I haven't. I should have just have it. This is a completely static image. So, as optical illusions work this way, our vision is extremissive. Optical illusions only work because they fool us into thinking that the interpretations we are projecting onto our visual plane are to be believed when they're not. There's nothing moving here. Just put up your hands if you can see motion, and put up your hand if you can't. Most people can't. It doesn't matter. Some people just can't. Don't worry. It's peripheral vision. So you're probably like me. Your peripheral vision is probably not so good anymore. But that's very rude. I apologise. Now we are going to have a GIF though. There are people doing. Who are the biologists here? Give me a wave if you're doing biology. I know there are. Don't be shy. Fantastic. Great. So I've got one thing that's kept me young. I didn't do biology at high school at all, which I'm now kicking myself for. So I'm going to have to. I'm having to run to keep pace with my biology friends now, because I realise the physics I've done for 20 years on macromolecules and membranes is physics rather relevant to biology. So I'm working with biologists, and I had about 10 years ago a sort of daydream of information transfer in. This is a picture of a protein bound to DNA. There's in different representations. There's the ribbon diagram of the protein. It's actually the catalytic activated protein in E. coli in the bacterium. It's bound to bacterial DNA. And this is one of those systems where information has to transfer through the molecules. But the story of my own physics, by the way, has been the story of noise. And if I run a computer simulation of this protein at room temperature, it comes alive, and it is very important. It's very important. This is a gift that physics can give biology, to recognise the importance of Brownian motion, this heat, this thermal noise. All these lovely structures we draw in our textbooks are all deeply compromised by thermal fluctuations. And all those awful movies that biology students get shown of how protein synthesis works, or how molecular motors work, of little myosins walking along. It doesn't happen that way. It doesn't happen that way. Everything's jumping around like mad. You can hardly see the order for the chaos. But I'm fascinated by how order arises out of chaos. That's my research goal. How does order rise out of chaos? And this is the chaos of this molecule. And there are wonderful ways in which it turns out that biology gets signals through this noisy place, not by fighting the noise, but by riding on it, like a sort of wave. And that's another talk for another day. But I remember when I first saw that picture, I didn't see the computer simulation, I saw this whole molecule come alive in my head and was doing a sort of strange mental experiment that then took 5 years to get the theoretical physics out after that moment. But there's a sort of visual core. And I suppose if I were to, but that's not the most beautiful visual aspect of science, I think we know. If I were to identify one great cultural gift of science in the 20th century, we would have to agree with Einstein that imagination is more powerful than knowledge. And what he imagined, so if you want to put general relativity into 4 words, gravity is pure geometry. That's what he did. And it's beautiful, and anyone can understand it. That what we think of as an attractive force, we taught that in high school, is better understood as the curvature of the universe and the motion of bodies as being not somehow apples tethered on the end of strings or baseballs on the end of ropes, but as objects in free fall, but in a curved space, and that the same objects that move in this curved space also cause it to curve. Gravity and motion in gravity is pure geometry. It's lovely. Now, I mentioned this extraordinary insight into how very few people today, very few scientists particularly, seem to reflect on this imaginative process. And it turns out that I claim that the last century in which people had really sufficient contemplative time and depth to think philosophically and indeed theologically about these things was the 13th century. Father Alan was kind enough to mention this project that I have with medieval scholars and scientists all reading we're reading the works of a former Bishop of Lincoln. Here he is, Bishop Robert Grosseteste. He was master to the early Oxford Franciscans in the 1220s, and in that period he wrote about colour, sound, light, the spheres, the planets, extraordinary stuff that belongs in the history of science on the way to what we call the scientific revolution. But I want to read a paragraph here that he gives in his commentary on Aristotle's posterior analytics, and think if he understood this, there is no way that science can be restricted to the early modern period onwards. Solertia is a Latin word coined by James of Venice. It's sort of the scientific imagination. It's the penetrating power in virtue of which the mind's eye, vision again, does not rest on the outer surface of an object but penetrates to something below the visual image. Monet, theoretical physics. For instance, when the mind's eye falls on a coloured surface, it doesn't rest there but descends to the physical structure of which the structure is an effect. It then penetrates this structure until it detects the elemental qualities of which the structure is itself an effect. That's translated almost verbatim from the Latin, which is why it's a bit clunky, but you can see the thought is far from clunky. The thought is beautiful and full of imagination. I'll go straight to, we've only got a few minutes left, so I must take us on rapidly to the textual. I said that there was a long entangled story between the novel and scientific experiments. And I saw the eyebrows go up. But let's listen to Joseph Priestley. 1761. Works of fiction, discovery of oxygen, right? Resemble those machines which we contrive to illustrate the principles of philosophy, such as globes and orreries. It was obvious to Priestley. He only had to say, he didn't have to explain why that was. His lecture, the people at his lecture were supposed to, oh yeah, I suppose they do. Okay, why is that? Let's visit Iris Murdoch, novelist and philosopher. Novelistic writing, she says, enables attention to the inexhaustible detail of the world, the endlessness of the task of understanding, and the apprehension of the unique. Aha. You could see, you could suppose I said experimental science. Can you see in the beginning of that sentence rather than novelistic writing? It would work, right? And this is why it works. You see, again, we look at history through the wrong end of telescopes here, don't we? How stupid the medievalists were, weren't we? Not to have invented the experimental method. How foolish. It's so obvious that experiment is the way to go. Actually, no. If you think about it, it is not at all obvious that to do something as oversimplified and as artificial an experiment. Okay, you want to learn something about the cell. So we put in a few membrane molecules and one protein and see what happens in the test tube. Well, that's nothing to do with reality in its full unbridled complexity. That's a real problem with experiment. Experiments are not by any means, obviously, the way to learn about the world. And that's why it took till the 17th century to get the experimental method. And what's more, you needed something as foolish as Christian theology, the Christian theology of Grosseteste and Bacon, to kickstart the processes that led people like Bacon, Robert Boyle, the founders of the Royal Society, to invent the experimental method. But there were wonderful critiques of how stupid it was. My favourite critique, and she's the first woman to attend a meeting of the Royal Society, is Margaret Cavendish. She was very critical of the experimental method for just this reason. She genders this as well, actually. Basically says, toys for the boys. We girls will just think properly about the world and we'll get there first. But she puts her criticism into a novel. For my money, this is the first science fiction novel, Blazing Worlds, in which she creates a world which one can visit via the North Pole, which there are animal-headed creatures, including scientists and philosophers, whose arguments only get worse when they're given telescopes. Because as well as arguing about the meaning of what they're seeing, they even argue about whether their instruments work or not. So right at the heart of the beginning of experimental method and novel, we have them both. The metaphor of reading and writing nature pops up as well, as it has throughout all history. Here's Robert Boyle talking about The World's a Great Book. We won't go into details here. And Daniel Defoe, arguably the author of the first non-science fiction novel, Robinson Crusoe. Robinson Crusoe. Think about it. You put one man on one little island with a few sheep and a goat, nothing else, until he sees some footprints that aren't his own. It's very like an experiment. It's controlled, it's simplified, and you sit back and observe. And the number of novelists that talk about writing in precisely the same language with which scientists talk about observing experiments, they don't make their characters do what they want them to do. You talk to any real author of a novel, that's never the language they use. The language they use is of sitting back and watching what their characters do, and not writing the chapter that they're satisfied with until they're doing something consistent with their characters. So it turns out that the best source for all this is Henry James, The Art of the Novel. And at one point in the chapter I wrote about this, I've put side by side a couple of fascinating reflections on the art of the novel. And just to pick out, I said the story would pop up. In other words, I don't know if you can see in these words, just pick up the highlighted words here, we won't go through the text, but James is talking about the stages of the creative process of writing a novel. Ideation, observation, incubation, you just got to rest and think when you can't struggle through to the answer yet, illumination, that aha moment, and the verification, which is the working out at the end. A generation later, a scientist called William Beveridge, he's a physiologist, wrote a book called The Art of Scientific Investigation. There it is. Using the same language, the same genre, actually the genre is Horace, it's Ars Poetica, the art of poetry. And there's the scientific method, but the whole scientific method, including ideas, being talked about in the same breath, in the same form, in the same language. The conjuring up of ideas is not deliberate, voluntary act, it's something that happens to us rather than something we do. That could have been written by a novelist in the 19th or 20th or any other century. The Romantic period, remember the story, the period in which Keats started identifying science as sucking like a Dementor from the Harry Potter books, you know, the lifeblood out of imagination. He's not the only voice. we have other voices in the Romantic period which is highly ambiguous in this sense. Wordsworth thought the day would come when science would be as inspirational of poetry as any other theatre of human engagement. But here he is, explaining why it's not true, yet it's because science is private, it's not shared. And elsewhere he says in the lyric ballads that this will happen when and only when science is shared among living and suffering beings, but we've kept it private. So Wordsworth's vision has not come to fruition. Let's come this side of the Atlantic and talk about Ralph Waldo Emerson. Emerson, one of the great transcendentalists, of course, wrote about, almost the last to write about science and imagination, and to write about nature in a genre that was both poetic and scientific exact. Humboldt is another example. He's talking about Goethe, who's here, who's the inspiration of them both. So I think at this Romantic period there was a sort of parting of the ways. But in the 20th century, this entanglement between science and the novel, le roman, continues. Here's Pat Waugh, my former colleague in the English department at Durham, talking about Virginia Woolf's The Lighthouse, which is itself a reflection about poetry and the creative process. But look at what Pat, a professor of English, says about it. It's fully part of the entanglement of subjects and objects in life as they enter each other's force fields. And the way that this novel, of those of you who know it, To the Lighthouse, plays with distortion of space and time. It plays with it in a way that I write, couldn't have been, couldn't really have been done in any other century. So, super briefly, we're just at the end. We've got one more chapter to go, haven't we? And then we're done. Mathematics and music. Well, let me just visit this ever so briefly, because I almost have nothing to say. We're treading on holy ground here. This is the abstract world of imagination. This is Poincaré, the French mathematician. I found some mathematicians from previous centuries who've reflected, like Robert Grosseteste does in the 13th, on the creative process. And when they do this, they can only explain the provenance of mathematical ideas by conjecturing that in the hidden parts of our minds, the non-conscious parts of our mind, is a creative aesthetic that's working even when we're asleep, certainly working when we're not conscious, and is somehow delivering to us these aha ideas. Here's George Steiner talking about the allegory of mathematics, which is music. But if I'm trying to solve where mathematics and music meet, it might be in my conversation with musicologist Julian Horton, who is a great romantic like me. He's a studier, he's a professor of romantic form, and we sat together and worked just in the same way that I enjoyed a visit to Philadelphia's art gallery and looked at the Monet. I had great fun with Julian Horton working through my favourite piece of music, which is an extraordinary piece by Robert Schumann. It's a concerto for a quartet of French horns. And orchestra, it's fabulous. But no one had analysed it, so we sat down. I wanted to see how a musicologist works on this. It's part of his project too. And at some point, the details don't matter. They're in the book if you want to find out about them. But he said this: what distinguishes composers of the first rank is their ability to set up strategic problems of harmony and to solve them. At that point, I heard echoes of what my mathematician friends, how they describe the creative process of making a mathematical proof, of just setting the next horizon for yourself creatively so it can be on the way to where you're going. Of course, music and maths share many other things in common. They both have notations which are either transparent to you or completely opaque. Some of you will love the music and some of you will say, I have no idea what's going on there. Some of you will love the maths and others will say, I have no idea what's going on there. But I've got fascinated by the creative potential of the symbolic and by what mathematicians and composers, how they talk about moving the symbols around in creative, imaginative ways. What's going on there is a quartet of French horns playing symphony. What's going on there is a diffusion of particles, as a matter of fact. Wilmer's Presson. there's a wonderful story I tell, which I won't have time to tell you now, but it's in the book, by my favourite professor of chemical engineering, Julie Cornfield at Caltech, whose group wanted desperately, this is the desire, to create an additive to jet fuel that would prevent that ever happening again. And you can do it. You know it's true. We know the answer now. No crashed jet ever has to explode in a boiler flame ever again. You can probably guess which event it was that catalyzed their desire to solve this problem, but they had absolutely no funding for it. So it's an extraordinary story of funding and love and desire and hope and all those theological emotions that were driving a piece of science. And Julie is the most honest engineer I know. Here's Japanese, Leo Izaki, Nobel Prize for Electron Tunneling. What's he say about this duality of science? The other face of science, fantastic, subjective, individualistic, intuitive. Scientists use their imagination to grope forward, a desperate struggle, trial and error, seeking out the secrets of the universe. I'm glad I didn't read this when I started the book. I would have never written the book because he said it all, right? But there it is. But it's been said before. Gross test, 1215, in these outline of why we study the liberal arts. The works with our capacity consist either in sight, or in desire, or in motions, what we do. Sight first looks, then it verifies, and when the fitting or harmful have been verified with the mind within the sight, desire strains to embrace the fitting or retreat to itself. And the honesty of this 13th century theological philosophy that says it's not cognition, it's not emotion, it's not even ethics, it's all three go into what we do, whether it's scientific or in any discipline at all. And that brings me to my final point about purpose. And this is where we were talking about this before in the Augustinian Institute. The reason that any university should have a theology department, even if it's entirely secular, is because theology is the discipline from the humanities that has the critical tools to talk about purpose. Something from George Steiner, post-Holocaust atheist Jew, but very wise man, talking about art. And he identifies this as the purpose of art. It wakes into, it makes accessible, wakes into some measure of communicability, the sheer inhuman otherness of matter. And there's something about the human predicament that Heidegger and Arendt and Steiner and the medievalists also knew about, that makes us fish out of water in the world. Part of what we do as humans is to paint and weave and sing and storytell and love and play games and do all those other things in order that we might make our home in the world from which we are bizarrely estranged. And if that sounds like a Christian theology of fall and redemption, then that's not a coincidence. It's equally amazing that this atheist post-Holocaust Jew writes this in a book called Real Presences, where he identifies the narrative that illustrates the human predicament as the Easter narrative of Friday, Saturday, and Sunday. So it's a journey that started off as a journey talking about imagination in poetry and art and science, ends up taking us to the theological point of God and humans, the nexus of how we heal. And so thank you very much for listening to all that. And that's the book. Right.
Would you like to field the question?
Very happy to field the question. Yeah, let's have. Yeah, so we have a few minutes of questions. But who wants to pick up any of those outrageous things I said? Matt. Okay.
Thanks, Tom. This was great. I was wondering whether you could explain why that we have within the sciences so much of a tendency to erase the creativity component. I looked up. So Peter Medawar in 1964 has this BBC talk, and it's famous as an essay now called "Is the Scientific Paper a Fraud?"
Yeah.
Where basically, when we talk and report our science, we intentionally erase several of the components of the creation story that you're talking about.
Yeah.
Why do we do this?
It's a contingent result of how science has become professionalised and evolved. When I'm staying at the Royal Society in London overnight, so I do sometimes, I love picking out early editions of the first ever scientific journal, the Philosophical Transactions or Society. I love reading in 1712. And you'll open a paper, it'll say, "Sir, I was upon my horse last Wednesday morning, observing an interesting atmospheric phenomenon," blah, blah. And it's just this wonderful story. And the horse tripped up and I was lying on my back and there's this star. And it's a narrative. And so it wasn't then, it was becoming then. It's a complicated story. I think there's a whole, Peter Meadow actually wrote much more later on. It's to do with professionalisation. It's also to do with, it's partly to do with the insistence that science is the same for everyone. So the particular human observer, in order to underline the commonality, an electron for me is an electron for you. If I'm doing an experiment with a prism or with sodium chlorate, and you're doing an experiment with the sodium chlorate, the prism, you should get exactly the same results. That's how science works. So therefore, the logic goes, and Robert Boyle is partly to blame for this in a way, one should start writing in the passive voice. It was observed that, rather than I observed, and so one slowly distances the human experience from the science. So I understand that motivation, but it loses honesty. I think that's my answer, but it's a much more complicated answer throughout the centuries. But it's a great, great question. Thanks.
How do you feel about your whole approach to these issues in a world where things are coming down more and more to whether a computer chip is on or off?
So the question is, what about possibly artificial intelligence or computing world, an electronic brain sort of world? I feel about them even more strongly because we live in a world where we've all got these phones, but it's a bit-ridden world where the computer chip is on or off. Zeros and ones. If a 0 and a 1 were a black marble and a white marble, and we had a 0 and a 1 marble for every 0 and 1 that's in our phones today, we couldn't breathe in this room. We'd be overrun by little 0, 1 marbles, right? So these zeros and ones fill our world. But like all technology, they are excellent slaves and very poor masters. So I think my answer to you is that this sort of story, I call it a story not because it's false, it's true, but this sort of story is even more important in a world where the zeros and ones threaten to become our masters rather than our servants. And we need to recognize they are part of our creative palette. I think we can be very creative with zeros and ones, but we mustn't let them instantiate the prediction of, if you like, John Keats. That they really could sap the meaning and imagination out of the world. But I'm an optimist. I'm optimistic about this. I don't think they have to, but I think we need to tell this sort of story more. Don't know whether you'd agree. Madam, yeah.
I was wondering, the difference between language in science and poetry.
Yes.
And I guess even if you look at music, it becomes even more, there's difference. But there's, in science, in mathematics, there's that, urge for precision.
Yes.
The equation is very precise.
Yes.
It tells everything.
Yeah.
The language that we use has to be very exact. On the other hand, poetry, the more ambiguous you are, the more levels of meaning you can include, and it's just so different, I think.
Well.
So I wonder if you could talk to that a little bit.
Thank you.
Music even more because we don't even have the words.
I wonder. The ambiguity of meaning. So when you get into, the method. Say, let's take that mathematics, mathematical science. Yes, there's a sort of pretense that mathematics is rigorous and formal and exact. The physical sciences are sometimes even called the exact sciences, aren't they? I really don't like that. That's also dishonest. sciences are not exact. Perhaps mathematical, yeah, some of pure mathematics really is exact. Grosseteste, by the way, has this wonderful insight into the difference between physics and mathematics. So in that same work, his commentary on Aristotle's posterior analytics. Again, the medievalists impressed me so much with the honesty they have about scientific method. He says this lovely thing, I paraphrase, he says, that God does with physics what we can do with mathematics. You see, when we have math, he knows about axioms. We have the axioms of mathematics. He means pure mathematics. He's talking about Euclid probably. And we can deduce what happens as a result of those fundamental axioms. We don't know the axioms of physics, but God does. So we have to find those out. He sets us a sort of puzzle. And so Bacon, inherited all this. But when we do mathematical science, it's inexact and ambiguous in just this important way. And it's kind of important that theoretical physics is a bit ambiguous, because that leads to creativity. So I've had many occasions in my research group with colleagues where we've had a conversation and there's been a misunderstanding because there's an ambiguity. But ambiguity, as you know, can be very creative. So I've said something, my colleague has said, oh, you mean this? And I said, no, I didn't mean that at all. But now you've said it, that's rather a good idea. Was that his idea or her idea or my idea? There is a deliciousness in which creative mathematical physics gives an ambiguity which is creative in a very similar way to a poet. And I jumped over this, but I think there really is an analogy to be drawn between poetry and science. And I think Shakespeare knew about it. So this is Theseus in the final act of Midsummer Night's Dream when he's doing all the lovers are in love with the right lover and not the wrong lover, and everyone's back and it's all happily ever after. And then of course this is a marvellous setting for the philosopher to come and pontificate about the lovers and the poetry. Here's the poet's eye, in fine frenzy rolling, doth glance from heaven to earth, from earth to heaven, and as imagination bodies forth the forms of things unknown, the poet's pen turns them to shapes and gives to airy nothing a local habitation and a name. And I've always thought, ooh, what does science do other than give to airy nothing? What does quantum physics do to give to airy nothing? That's what electrons are, airy nothing. A local habitation and a name. It's a wave function. It's a Schrödinger equation. That's poetry for you. And in a sense, if there is a sort of exactness to poetry as well. It's called form. This is iambic pentameter. Shakespeare wrote sonnets. And I don't know if you ever remember, I remember very few lessons of my high school years, but the one lesson I remember is when our English teacher told us about the sonnet. And I'm sure you've all had lessons of the same. And the teacher says, when your imagination is so powerful, that it's so productive, it's just producing words and ideas and stuff, and it's a horrible mess. The reason poetry has form is because you've got to put this imagination into form in order to turn it into beauty and coherence. And that's why we have a sonnet. Well, what could call on a greater power of imagination, I said this before, than to reimagine the entire universe? And what could constitute a tighter form than the universe as it exists, as we observe it? So I think there is a sense, thank you for it, there's a sense in which doing science feels like the constraint of the impact of imagination form, which is what poetry is. I haven't articulated that very well, but thank you. I think it was one and two, we've got time for two more probably.
Yeah, I'm very sympathetic to everything you've said, but there is a certain picture about imagination's relation to science, which I'm used to, my philosophical background, that I'm wondering you could speak to it. Very simply, it's this. Mm-hmm. Creativity is fine when it comes to theory discovery, but when it comes to theory verification, the imagination gets kicked out of the door, and science is more properly the verification, not the discovery part.
Okay, well, so...
I don't agree with this view.
Yeah, no, I disagree. So obviously science is not just the verification part, because there is no science if you don't have the ideation part. So the first thing I want to say is that the whole process of science involves both ideation and verification. The second thing I would say is that the novelist does just as much verification. I mean, for example, James actually uses that word. Henry James uses the word verification to describe his process as a novel of just making sure everything's tidy and fits, and are his novelistic ideas consistent and coherent with his characters. And it's a detailed process of checking. And something that I've learned that artists of all kinds, you say just as scientists are a bit stumm, a bit quiet about the imaginative phase of what they do, so artists of all kinds, I've had to get them to open up a bit about the verification phase, about the 10 times the paint scraped off the canvas because it's not right yet, the experimental check of the idea's work, the redrafting of the poem, the rescoring of the symphony. There's a wonderful example. I was in Oxford at a discussion between Roger Penrose, the theoretical physicist, and the wonderful English-Nigerian author who wrote The Famished Road, Ben Okri. He's a wonderful guy. And at one point, Roger Penrose just lost it. To say, oh, I don't know what we're talking about here about novels and science. Look, science has to be right. There's no room for imagination in that. It's just got to be right. You novelists can make your characters do whatever you like, and you've got complete freedom. It's just different. And Ben Okri took a big breath and said, Professor Penrose, do you know how many times I redrafted my last novel before it was right? The answer was 24, by the way. So, yeah, I think there's more to say there.
What I was going to say is that if you have a proof, a really beautiful
Yes.
mathematical proof,
Yes.
it's like a poem
Yes.
because it is right. And it doesn't say that you haven't done a dozen other drafts in order to get that exact thing in a small enough and coherent enough idea so that you're putting your ideas down in, if you will, like a sonnet,
Yes.
in a perfect way, as best as you can do it.
Yeah. It is.
We do not necessarily say, hey, would you like to see the papers on the floor that I ripped up because they weren't quite there? No. It all works. It all works. It all works.
You are a mathematician, madam, I understand. Yes. I know can hear this from experience. Yes. This is beautiful. This is exactly how mathematicians work. It is a poem. It is a poem in many ways. One thing that we ought to be said is that mathematical proof is like a poem because although mathematical theorems have, depending on your take on this, are in some sense platonically there in idea. The Pythagoras' theorem is true but there's a wonderful book you can buy of about, I think it's 250 different proofs of Pythagoras' theorem. But proofs of those theorems are as many and as multiple and as diverse and as aesthetically nuanced as there are mathematicians. And the aesthetic of a proof, so proofs are not contingent, proofs are not definite, they're contingent, they're created, they're what this wonderful lady does, and I wish I could do this myself. And there are proofs that you can tell the mathematician when you know your field, you can read a proof and you know whose proof this is, because it's the way they think. It's like you can look at a Monet. No one else paints like that. You can read a Shakespeare sonnet. No one writes sonnets like that. That's Shakespeare. There's ways of creating mathematical proofs of different types of elegance and style that are deeply personal. They are, of course, formal, and they have this aesthetic. And the beauty, yes. So where does the beauty come from? Do you know what it is? If someone here said, I don't understand why mathematics is beautiful, what would you say?
I think it's the finest working that your mind can possibly put down. And it's the mind that is beautiful. And you can see it in a mathematical proof or in a beautiful sonnet.
Yeah.
Or
I had
in
this.
a magnificent painting or in a beautiful symphony.
Yeah.
Yes.
I had this particular mathematics I love. wanted to choose, I chose a particular symphony. It was the concert for four horns. I've actually, just like I did in the book, what you'll find, I do this juxtaposition thing. I don't know if it works or not. But the Henry James and the Beveridge science text and the literature chapter and the maths and music, I just juxtapose an analysis of this extraordinary piece of music, which is all its logical contours and endpoints, with the fluctuation dissipation theorem, which is probably a pure mathematician, I think, but it's a kind of on the borderlines between theoretical physics and pure maths. And I suggest, even if you don't like the mathematical notation, I suggest look at the way the objects, the H, Nero, and the Q dance around each other. Can you see this second line there? And there's a sort of beautiful dance of mathematical operators inside the equation that completely changes the way you interpret the meaning behind a line of algebra. And it's like an ambiguous word in poetry that completely shifts your vision between the first part of a sonnet and the second. And then it takes you, and then the algebra itself becomes transparent, and you look through it onto this other vista of this world of abstract ideas. Well, thank you so much for enriching our evening like that.
So, in so many ways, what we think of as a beautiful composition of music cannot exist if there isn't dissonance along with harmony.
Oh, yeah.
And it almost seems to me that for a scientist or for science to try to presume that somehow they've got the perfect answer is only to notice that it's on too small a scale. Because the perfect answer always leads to some bigger answer or some bigger proof. And it's almost like music becomes a way of interpreting how we use our imagination precisely in imperfect ways, rather than perfect steps all along the way.
Oh, yes. So, yes, dissonance, imperfection. I ought to have said much more about that, but we would be here for another hour, and we're already well over time. Oh my goodness! So we finish at 5:30. What's going on here? We should let these poor people go. But the delicious beauty of the incomplete is important, of course, in every creative endeavour. You want to trust out these trite things, perfection being the enemy of good, don't we? But it's really true that okay, I guess a proof had better be perfect, hadn't it? But then it's not, even the mathematicians, for which proofs have to be right, there's always a better proof. My proof is a bit clunky. Yes, it is a proof, it works, but it doesn't give me the I'm trying to work on a little problem at the moment. I don't know if you know, it's nothing to do with what I'm actually working on, but it's just a fun bit of mathematical physics. If you ask, suppose you have a flexible wire on which there's a bead it can travel down, and you ask, I'm going to start the bead sliding here, and it's going to finish here, and I can give as much wire as it wants, and I can give that wire any shape I want. What's the shape that will get the bead fastest from this point to that one? It's called the brachistochrone problem. And so what I could do, you might think, well, the shortest path is a straight line. So I have a straight line. Turns out to be not the right answer, because of course, if I make it go down faster, it gets faster quicker. So there's a little bit of a payoff. If I make it curve down, it gets faster, and although it's got slightly longer to go, it goes much faster for most of the way. So what is this curve? The answer is it's exactly the same shape as the curve traced out by a piece of chewing gum picked up by a bicycle wheel, called the cycloid. If it goes dum dum dum, it's that upside down. It's the cycloid. Okay, now I know the proofs of this thing, but what I want is a proof that's as transparent as a stained glass window. That you can say, aha, of course it's a cycloid. Do you know what I mean? So there's and There isn't one yet. But I think in the literature there is someone there, but there should be a one-line transparent proof that you hardly need to write down a line of algebra. Of course it's got to be that. There must be a way. I don't know, if perhaps someone in this room knows the answer to this problem, I'd love it. But it's really bugging me. I don't know if that's not an answer to your question. No, your question was wonderful, but it's just there's a creative grit in the oyster that's part of the process. I think that's what you were talking about.
Thank you for leaving us with the mystery.
Okay, cool. Thank you so much. That's been really a lovely discussion. Thank you.